Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 6 today. Chapter 6 is a lot about ratios and proportions and similar figures and the relationships between similar figures. If you recall from Chapter 4, I believe we did some stuff with like side, angle, side. In Chapter 6, there's also like similarity shortcuts like side, and stuff. So that'll be kind of interesting when we get to that. So today's about ratios, proportions, and the geometric mean. Our essential question is, what are some practical applications of ratios and proportions? So, that's weird. We have a warm-up here to solve the following proportion. So there's a step for doing this. Why don't you guys see if you can pause the video and figure out what the solution is. Go ahead. All right, so for solving proportions, what I like to do, some teachers don't like to do this, the math teachers, but what I like to do is just cross multiply. I think it makes things pretty easy. So we have 2x times 7 equals 7 times 4. What's 2x times 7? That is 14x. What is 7 times 4? That is 28. Now how do we solve for x? What do we do here? Divide by 14. And we get x equals, what's 28 divided by 14? That is 2. All right, sounds good. So we're going to be using some of those steps today. All right, ratios. We got some definitions here. A ratio, if A and B are two numbers or quantities and B does not equal 0, then the ratio of A to B is A over B. Okay, and the operation that we use with ratios are division. Okay, so it can be written as A over B, like this over here. It can be written as A with the word 2, A 2B, or it can be written as A colon B is another way to write a ratio, okay? Just be careful. The way you write ratios is that the first thing needs to go first on top, and then the second thing needs to go on the bottom when you're writing ratios with a fraction, okay? So if you did B over A, that would not be the same thing as A over B. Okay, and a proportion is an equation that states that two ratios are equal, okay? Means and extremes, this is basically, these are the means, these are the extremes. I don't really like this because if you switch the fractions, they become different. So we're not going to talk about that too much. And the geometric mean, if you're solving this proportion over here, it's the positive number x that makes that true. Okay? All right, sounds good. Okay, so let's do some examples here. We're going to simplify some ratios. All right, we're going to compare ratios. One thing we need to put here is that we need the same units. We need the same units, okay? So, if we do this, let's see here. We have 76 centimeters to 8 centimeters. So first things first, are they both the same units? They are. They're both centimeters. So we're going to write this as a fraction now. We're going to write the first number goes on top, so 76 centimeters. Over 8 centimeters. All right, and we're just going to reduce this. The centimeters are going to cancel. We're just finding like what the ratio is. What number goes into 76 and 8 nicely? Well, the factors of 8 are 1, 2, 4, and 8. 8 doesn't go into these numbers, but 4 does. 76 divided by 4 is 19, and 8 divided by 4 is 2. So the ratio of 76 centimeters to 8 centimeters is 19 to 2. All right, B is a little bit trickier because we have 4 feet over 24 inches. And as you recall, we need to have a common unit. Do we have common units here or no? Okay, so we're going to do what's called unit cancellation or unit conversion or dimensional analysis. This is kind of useful in chemistry. So we can go either direction. We're going to do both though, okay? So we're going to convert feet to inches and inches to feet. So here's what we do. We're going to do 4 feet. We're going to kind of make these brackets like this. Okay, we're only converting 1 unit, so we're going to put this over 1. We're going to kind of make these brackets here, okay? So the way we're going to do this is we're going to use the conversion factor of like feet to inches, and then we're going to kind of use that to be able to figure out how to like multiply this or divide this, okay? So how many inches are in a foot? There are 12 inches in 1 foot. If we want to get rid of feet, we want to go to inches. So if we want to cancel feet, we want to put it diagonal from where it is. So we're going to put 1 foot down here, and we're going to put 12 inches on top. And if the units are diagonal from each other, they're going to cancel, so feet are going to cancel. Okay? Then we're going to multiply straight across the top and straight across the bottom. So straight across the top is 4 times 12. Bottom is 1 times 1. What's 4 times 12? That is 48, and 1 times 1 is just 1, so we get 48 inches. So you can see that 4 feet is 48 inches. You may have been able to do that in your head, and that's okay, but just be prepared. There's going to be some examples that, like, you know, in your career as a student that will require multiple conversions, and that's harder to do in your head. Let's go the opposite direction now. Let's do 24 inches, and let's go to feet. So 24 inches goes here. We still have the same conversion. We have how many inches are in a foot? 12 inches in 1 foot. Where am I going to put inches if I want to cancel them? I'm going to put inches in the bottom right. So we have 12 inches per 1 foot. Inches are going to cancel. Multiply across the top. 24 times 1 over 1 times 12. 24 times 1 is 24. 1 times 12 is 12. 24 divided by 12 is 2 feet. And you can see these are left over here. So we got feet and inches. Okay? So we can do this both ways. We can do 4 feet over 2 feet, which is 24 inches. If we reduce that, we got feet over feet. 4 divided by 2 is 2 to 1. Okay? Or we could do 48 inches over 24 inches. And you can see it'll still work out the same way, which will be 2 to 1. All right, those are the 2 examples we did. Why don't you guys go ahead and pause the video and do the checkpoints. Okay. So we have 4 meters to 18 meters. So again, we put the first number on top, 4 meters over 18 meters. All right. Common units. Yes, we do. Meters are going to cancel. What number goes into 4 and 18 nicely? 2. 2 goes into 4 twice. 2 goes into 18 9 times. So the ratio would be 2 to 9. All right, this one. Let's just do, I think it'd be easier to convert, let's see here. It'd be easier to convert feet to yards. So let's go ahead and do that. You can do it either way. So we're going to do 9 feet, and we're going to convert it to yards. So how many feet are in a yard? There are 3 feet in a yard. If I want to cancel feet, where should I put feet? I should put it in the bottom here. So we have 3 feet is 1 yard. Feet are going to cancel. Multiply across the top, we have 9 times 1 over 1 times 3. So we have 9 divided by 3, which is a 3. Wait, that's not right. It sounds goofy here. Oh, it's just 3 feet, right? Or 3 yards, my mistake. I goofed it up. 3. This is 3 yards. So 9 feet is 3 yards, and now we can take that. We can do 33 yards over 3 yards. And you can see the yards are going to cancel. 33 divided by 3 is going to be 11 to 1. Okay? All right, moving along here. We have property of proportions. We kind of talked about already in the warm-up. But basically, the cross products, or when you cross multiply, they're going to be equal. So, for example, we have A over B equals C over D. Then A times D equals what? B times C. So same thing over here. 3 times 4 equals 2 times 6. What's 3 times 4? It is 12. And what's 2 times 6? Also 12. So you can see that when you have proportions that they when you cross multiply, they're going to be equal. All right, we have a couple examples here. We have 3 over 4 equals x over 16. We're solving proportions, so we're going to cross multiply again. So we have 4 times x is 4x. And 3 times 16 is 48. Divided by 4. And we get x equals 48 divided by 4 is 12. Okay. All right, B is a little bit more challenging. We have 3 over x plus 1 equals 2 over x. We're still going to cross multiply here. So we have, we could do 3 times x equals 3x. And then the other thing we have to do is when we have like x plus 1 or like a longer like expression, we need to do 2 parentheses times x plus 1. We need to multiply 2 times everything down there, okay? So now what do we do? We're going to distribute. So we're going to distribute, so 3x equals 2 times x is 2x. 2 times 1 is 2. Now we got to get x on one side, so we're going to subtract 2x. And we get 3x minus 2x is x. So we get x equals 2. All right, I'm going to leave it zoomed out here. Why don't you guys go ahead and try the checkpoint, see how you do. Okay, checkpoint 5 here. Solve the proportion, cross multiply. 2 times y is 2y. 8 times 5 is 40. Divide by 2. Y equals 20. All right, same thing over here. Cross multiply. We have 3 times 2x is 6x. And then we got to do 9 times x minus 3. Distribute. So we get 6x equals 9 times x is 9x. Minus 27. 9 times negative 3. Now we got to get all the x's to one side. How do we do that? Minus 9x. So we get negative 3x equals negative 27. Divided by negative 3. X equals 9. All right, sounds good. Okay, next example is a little tricky, okay? There's a lot of steps here. Just stay with me and feel free to rewatch through the video if you need to, but let's do this here, okay? So it says you're painting barn doors. You know that the perimeter of the doors is 64 feet, and the ratio of the length to the height is 3 to 5. Find the area of the doors. Okay. So I guess it says, so here's what we're going to do. We're going to write in the blanks here, write the formulas for the shape being used in the problem, and also for the length and the width. Okay. So we're talking about a rectangular thing here, right? So what's the formula for perimeter of a rectangle? Hopefully you remember it's 2 lengths plus 2 widths. Okay. All right. What else do we know here? Well, we know that the ratio is 3 to 5, okay? So what we're going to do with this is we're going to use like 3x and 5x, okay? It's going to kind of help us kind of compare these, okay? So I'm going to say the length equals 3x and the width equals 5x, okay? By adding x in there, we're going to have a common variable, which is going to make it easier to solve. What else do we know? Well, we know that the perimeter actually equals 64, okay? All right, so it's kind of weird, but yeah, basically we're just going to be, for these kind of ratios, if you just change them and put x in them, it's going to give us a nice way that we can solve by using a common variable. It's going to make it easier to compare here, okay? All right, next thing we're going to do, step 2, is to substitute into the formula and solve for x. So we know p was 64, 2 times the length was 3x, plus 2 times the width, which was 5x. Okay, so 64 equals 2 times 3x is 6x, 2 times 5x is 10x, so we get 64, 6x plus 10x is 16x. If we divide by 16, we get x equals 4. Are we done? Well, not quite. Now we need to plug in for the length and the height. So we're going to take, remember the length was 3x, and the width was 5x. So now we can take our x, do 3 times 4, which equals 12 feet. And we can do 5 times x, which was 4 for the width, which was 20 feet. And those are the length and the width. And the last thing we can do now that we have the length and the width is to use the area to find the area of the rectangle. What's the formula for area of a rectangle? It's length times width. So that's going to be length, which is 20, times the width, which is 12. Actually, I flipped those around, but that's okay. That's still going to be the same thing. It's going to be 240. It's going to be square feet because it is area. Okay, kind of a tricky problem, but I'll leave it zoomed out here. Why don't you guys go ahead and try the checkpoint. And the checkpoint's going to have some weird numbers for the, I think, the x value. So just do the best you can, and we'll go through it in a second. Okay, checkpoint 3, the perimeter of a rectangular table is 21 feet, and the ratio of its length to its width is 5 to 2. Find the length and width of the table. So same thing, we're going to do perimeter equals 2 length plus 2 width. We know the perimeter equals 21. We know the length, the ratio of length to width is 5x, and the width is 2x. So we're going to do 21 as the perimeter, 2 times 5x, which is the length, plus 2 times 2x, which is the width. So 21 equals 10x plus 4x. So we get, let's see here, 21 equals 14x. Divide by 14. And we get, if we simplify that, 21 and 14 are both divisible by 7. So we get x equals 3 over 2. Then we have to plug into that problem there. So the width was 2 times x, which is 3 over 2. And 2 times 3 halves is just going to be 3 feet. And the length might be a little bit weird, which is going to be 5 times 3 halves, which equals 15 over 2, which is approximately 7.5 feet. Okay? Kind of a weird one. All right, example 3 is kind of a similar thing, but just with triangles. So let's see how we do with this. So the measures of the triangles in triangle BCD are in the extended ratio of 2 to 3 to 4. Find the measures of the angles. Okay? So we're going to draw our triangle again. I like to draw my scalene triangle. Okay? So we're going to do the same thing with 2x, 3x, and 4x here, okay? So we're going to call this angle 2x, which is the smallest angle. The next biggest angle is going to be 3x. And the biggest angle is going to be 4x. Now, what do we know about the angles of a triangle? They add up to what? They add up to 180. So we can do 2x plus 3x plus 4x equals 180. All right, what's 2x plus 3x plus 4x going to be? That is 9x equals 180. And divide by 9. We get x equals 20. Are we done? Well, not quite. We got to plug in these ratios now. So we had 2x, 2 times 20, which equals 40. We had 3x, which was 3 times 20, which was 60. And we had 4 times x, which is 4 times 20, which was, these are all degrees, which was 80 degrees. So we had 40, 60, and 80 degrees. Okay? All right, last example is very similar. Go ahead and see if you can figure it out. Give it a try. All right, checkpoint 4, same thing. We draw our triangle. We have x. This is x, 4x, and 5x. So we have x, 4x, and 5x. They all add up to 180, so x plus 4x plus 5x equals 180. Add them all up, we're going to get 10x. These are all like terms here. Equals 180. Divide by 10. So x is going to equal 18. And then if we plug those in, we're going to get 18 degrees, 72 degrees, and 90 degrees. And those are going to be the 3 things here, okay? All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.